Hello and welcome back to Calc3. I see very low bandwidth on this lecture, so hopefully we get the video. I don't know. So the lecture is on tangent planes and linear approximation. Also helps will be featured in this, and all of this is developed 200 years ago or so to help us with calculations. So, at the time when this was developed, there was a need to compute 3D functions and all of that stuff. But obviously, without calculators and computers, that task can be very tedious. So what are the easy ways of going around it? Let me go back briefly to Calc 1. There we go, with K's, yes. So go back to Calculus 1, and in Calculus 1, you guys dealt with the tangent line and linear approximations and differentials. So the premise of the whole thing was, let's calculate the square root of 17, right? So calculate square root of 17, and as it goes, usually I say, okay, so you gotta paint a picture of you are at the desert island, and cell phone battery, calculator battery, and all other batteries are done and done. There's no solar chargers because you haven't packed that one on your cruise ship, and the Wilson is gone too. So the next best thing to do is to go to the beach, take a stick, and just calculate the square root of 17 in the sand, trying to kill time before events of lost or error or something start happening. So calculate square root of 17. So we are looking at the function square root of x, and the easy value to compute that is close to 17, that's very important, is 16, right? Because 16 is 4. So you have to look at what you're computing. So it's either square root of a number or a tangent of a number or an ln of a number, and you define a function looking at what function is used in your computation. And then you are charged with finding the closest possible value that you can compute without a calculator, right? And once you have, now obviously this doesn't work if you don't know any of the values, right? You should know basic values for every function, like sine of pi is 0 and ln of e squared is 2. So these kind of things you should know. So now, when you have these two things, you say, all right, to calculate square root of 17, I'm going to compute the tangent line at 16 and use the tangent line to compute 17. Now, tangent line is a linear line. So those calculations we should be able to do without a calculator, because you are just do multiplication and addition rather than actually figuring out the square root. Now, why this works is when you draw your function, you are going to have a value 16 that you can compute, and there's a notification that reconnection is successful. Let's see. So now what happens here? Well, I'm going to find the tangent line. So we find that the slope is going to be the derivative computed at a. The derivative is 1 over 2 root x, so 2 root 16. This is 4, so 1 over 8. So I have the slope is 1 over 8. And we know that the linearization is f of a plus f prime of a x minus a. So that's the tangent line written in a single formula. So linearization formula is f of a, that's square root of 16, plus 1 over 8 times x minus 16. So this is equal to 4 plus 1 over 8x minus 2. And the tangent line is given by 1 over 8x plus 2. So now I can calculate, I can claim that square root of 17 is approximated by L of 17, and L of 17 is obviously 1 over 8 times 17 plus 2. Right? So now you can go in a sand with a stick and divide 17 by 8, you will get 2.1125 and add 2 to that to get 4.125. So you approximated that square root of 17 is about 4.125. And then you get rescued. The first thing you do when you are on that rescue ship, it's not a food, it's not shower, none of that stuff, obviously. The first thing is clothes. As it generally goes in these shows, then you died because it was a dream and you were dehydrated and that was it. A grim picture, I understand, but that's what this section is all about. Now, come on! Is this with the rain that the network goes down?
On the streamer, you can actually see the numbers, but on the streamer, they're but you can see like approximation.
Yeah, we have network issues. So just imagine the problem I solved, right? I drew now the line through, and I'm going to write Calc3 now. And I'm giving it a title, Tangent Plane. As I am waiting for this to reconnect, which I don't think it will. Oh, come on.
The stream's still going on.
Yeah. The tangent plane. Yeah, but I can't get the projector to work because now local network is not working. I don't know how. How is it possible that like some stuff. Whatever. I have to restart. And that ends the stream. Ugh.